This lesson is going to explore some more challenging questions that involve converting expressions into radical form, meaning we're going to be doing things involving power over root, and that's going to be coming up very often. And we're also going to apply some of the higher level versions of rational exponent examples. And when we say rational exponents, we are talking about exponents that are fractions, not just exponents that are whole numbers, but exponents that are fractions. We're going to be using things like the power rule. So that's if you see something like x cubed, and then that's being raised to the power of 4. So you would be multiplying those powers together, and we would have x to the 12th. We'd be doing things like the same base multiplying rule, or even the very important negative flip rule. So if you were to see something like x to the power of -2, you would need to know to put a 1 underneath that, and then flip the x to the -2 to the denominator and make the exponent positive, and then there would be a 1 in the numerator. So if what I have just said and written on the screen sounds unfamiliar and something that isn't quite coming to your memory really quickly right now, then you need to go and revisit the previous videos and check out the examples that are in those videos in order to review. The entire lesson that we are about to do is only doing examples of the properties and rules that you already know how to apply. There's nothing brand new that's really going to be shown right here. It's all going to be things we've already been doing in the previous videos. So it is strongly recommended that you pause this video often and attempt the examples first on your own as we are about to go through them. So all right, here we go. We're just going to be simplifying some radical expressions, and some of them are going to be at a slightly higher level. Just the important thing is to read what the direction is asking for, to try what we have been working on from the previous videos, and to see how far we can get. So number one, we are writing an equivalent expression in radical form. So that's the key right there, radical form. That means at the end of the problem, we should have a radical sign. It means we are probably going to do things involving power over root. So if we take a look at the first example, we have x cubed, and it is being raised to the power of -4/5. And since we have a power being raised to a power, 3 is being multiplied by the -4/5, we are going to use the power rule and multiply these exponents together. So we want to remember 3 is going to just be 3/1. So when we multiply those together, you're going to multiply straight across, and 3 times -4 is -12, and 1 times 5 is going to be 5. So we now have x to the power of -12/5. But remember, we're trying to write things in radical form, not the form of a rational exponent. Again, rational exponent means the exponent is a fraction. So in radical form, we have to remember power over root. X, the base, is going to get a power of -12. So we're going to have that under the radical sign. And then the root is 5, so we're going to have that in the root position, the fifth root of x to the -12th power. Now, you could stop there, and that's a pretty good answer, but it is something truthful that needs to be said, that you're not supposed to end with a negative exponent if you can do a little more simplifying. So let's actually take care of that negative exponent by just putting a 1 underneath x to the -12th and applying the negative exponent flip and switch rule, which has been explained in some other videos. Move the x to the denominator, make the exponent become positive, so it's now +12, and since we were taking the fifth root of that, the fifth root symbol, it just tags along as notation. So the final answer could be 1 over the fifth root of x to the 12th. But if you wanted to go one step further, you could remember that x to the 12th is you're able to take the fifth root of x to the 12th because, another way of expressing this, it's like saying the fifth root of x to the 10th times x to the second power, which is also exemplified right there with the 2 copies of x to the 5th. Remember, if we are able to cancel out these x to the 5ths, then that means there are 2 copies of it that would come out of the radical sign and move to the front. Or another way of thinking about it is that it is just x to the 10th, and we would be dividing 10 by 5 and getting an exponent of 2 on the outside from right there. So let me just back that up, and a little extra work right there. So we have, and I see there's a little typo right there. I forgot there should be an extra 2 right there. Okay, so we now have the answer. If you were to take it this far, again, if you got as far as what's in the purple, that's a very good answer. If you understood how to move the negative exponent to the denominator, then that's even better. And then if you also understand that the x to the 12th power, we are able to take the 5th root of it, and because there are 2 copies of x to the 5th, then there is an x squared in front of that, then you are doing an excellent job. All right, let's move on to number 2. Little less going on in this problem. We have the multiplying, same base multiplying rule. So because both of the bases are x, y, and we are multiplying them together, we are allowed to add those exponents. And it is a 1/3 plus a 3/4. In previous videos, we've talked about exponents, so let's just go adding fractions, so let's just go through it quickly. We need a common denominator. That denominator is going to be 12. Do the same thing to the numerator with multiplying by 4 and 3, and you would be getting 4 plus 9 in the numerator to give us 13 over 12. And that is going to be the new exponent on xy. And I see I just forgot to get the letter y squeezed in there as well, just to have it be correct. And technically, let me just adjust that. The xy should be in parentheses because that is the entire quantity getting raised to the power of 13 over 12. So just to also fix that in the answer, the power would stay 13 and the root would be 12, but just move that 13 over. The y would stay under the radical sign. And actually, here's another little quick learning moment. If the 13 were to be placed on the outside of the radical sign, then that would mean the same thing as if the xy were in parentheses with the power of 13 on it. That's how you can write that the entire xy is being raised to the power of 13. Technically, if you had the 13 written right there without parentheses, it means only the y is getting the power of 13, and the x would therefore have a power of 1. But to show it with the entire thing, the xy, then you can put the 13 in that position right there. All right, let's do another example. Again, take a moment, pause, try to write this expression in radical form. And as a reminder, you want to work from the inside out. Do everything you can to simplify that fraction and then work your way to dealing with the 1/4 power. So take a moment and pause, try it. And all right, here we go with the explanation. So, working from the inside out, hopefully you would have noticed there is an f in the numerator and denominator. So the f in the denominator, because it has a power of 1, then it would be subtracting the 2 that was originally there by 1 to get an f of the first power in the numerator. And that is the same base dividing rule where you just subtract the exponents. You're going to notice that the g to the 5th and the 3/4, there was nothing to simplify with those. You had a fraction that was as simplified as it could get, and there is only 1 g in the entire problem. So what we have with working from the inside out is 3f g to the 5th over 4, and that entire thing is being raised to the 1/4 power. Now, we are putting this in radical form. There are a couple ways you can do this. I'm going to show you 2 ways. Here is the first way. You can take that exponent of 1 over 4 and apply power over root, abbreviated with the P and the R, and rewrite this. Now, that is the power of 1, and anything raised to the power of 1 is going to be exactly the same thing. The root being 4 does matter because the fourth root is going to allow you to simplify some things. But the power of 1 really doesn't have to be written there because anything to the power of 1 is itself. So putting things in radical form right now, we are almost done. We have to look to see, are there any fourth roots in the problem that we would need to simplify? And we cannot touch the 3, the f, or the 4 because all of those powers are 1. But we do have a g to the 5th power, which could be rewritten. And let me just draw over this in a larger pen. We could rewrite this as, since we are staring at a 5, we could make this into g to the 4th power and then a g to the 1st power because 4 plus 1 is 5. And now we can take the 4th root of g to the 4th, and that means a single g will come out of the radical sign for the final answer. If that was too much in one explanation, pause, rewind it, listen to it again. All of that was good stuff. It's why you're allowed to simplify the g to the 5th power. And I'll show you another way to approach this in a moment, but I think you're going to like this way a little bit more because it relies on power over root and something that was talked about in a previous video where you can simplify expressions like that. And as a quick test to make sure you are with what I'm talking about, let's just say you're going to take the 6th root, I know it's a root we haven't done yet in any of these videos, of x to the 19th power, the 6th root of x to the 19th power. Pause the video and try to do that quickly. If you can't do that, then this is the wrong video for you to be on. You got to go back. And here we go. So you need the 6th root, so you need multiples of 6 that go into 19. That is how many x's you're going to be able to take out. What I mean by that is, since 6 times 3 is 18, then we can think of this problem as x to the 18th power times x to the 1st power, and you're taking the 6th root of that. Because 18 is a multiple of 6, then you can just divide 18 by 6 and get x cubed, with the 6th root of x to the 1st power staying under the radical sign. And that would be the answer. And if that's not a good enough explanation for you, then you can think of it like this. Instead of x to the 18th, let's make it x to the 6th, x to the 6th, and I'll put that other one in front with an x to the 1 right there. Again, you have multiples of 6 and 12 and 18, or you can represent that by 3x to the 6th, and we are taking the 6th root of that. So because we have a 6 right there, we are allowed to cross off all 3 of those groupings, and that would be 3 x's that come out of the radical sign. And then that leaves us with the 6th root of x to the 1st power. Again, the same answer that was just up here. If that makes sense to you, then you are watching the right video, and if it does not, then you got to go back and look at some previous content. Let's now talk about the other way. Oops. We're finishing this problem up. Come on, back up, back up, back up. All right. Once again, all of that was now just to get us to the answer. G to the 4th, that's going to come out as a single G, and then everything else under the 4th root sign cannot be reduced any further, so it just tags along for the final answer. So a g is in front, and then the 4th root of 3f to the 4th with a g in the numerator, and as weird of an answer as that looks, that is the right answer. If that is not the easiest answer for you to understand, then here's just a very quick other way of doing it. Just got to back all this up. Okay. You could also do the g to the 5th power separation part and make it into a g to the 4th and g to the 1st. You could do that without doing power over root, because when the power of 1/4 is going to be distributed to all of the other exponents, you're just going to be doing a 4 multiplied by 1/4. And that power of 4 is really 4 over 1. And when you multiply 4 over 1 by 4, you get 4 over 4, which just reduces to 1. So it cancels out to a single g anyway, and that's just another way of thinking about the problem. That it's just an alternative way to approach it. You still get to the same result as the final answer, but the other way just involves you using power over root. All right, 4 and 5, pause these, give them a shot, and notice that we are writing these expressions using rational exponents. So we should not have a radical in the final answer. The final answer should have exponents of some type of fraction. So take a moment, pause, and give these a shot. And here we go with number 4. So right now, these are in radical form, and it would probably make sense to rewrite them using power over root. So the x currently has a power of 1, and since the root is 4, we can write it as x to the 1/4 power. And then the 2x, both the 2 and the x have powers of 1. So when you rewrite those using power over root, then both the 2 and the x will have a 1/3 with them. You could technically write it as 2x together in parentheses to the power of 1/3, but you're going to have to separate them anyway because all 3 of these terms you would need to assess if you can multiply them together and do other simplifying strategies to them, which you can do. What we have are 2 x's. They share the same base, so that means the multiplying same base rule is going to be applied, and that means we have to add the exponents together. So, and when those exponents get added together up here at the top, we have a 1/3 plus a 1/4. I'm going to assume that we understand common denominators to make these into 12s by multiplying the 1 and the 4 by 3 and 4 and yada, yada, yada. You get 7/12, and that is going to be the new fraction. That will be the rational exponent on the x variable. And then we now have our answer. We have written it with rational exponents. There are no radicals in the problem, and there is nothing else that can be simplified. So what you have right here would be the final answer. Taking a look at number 5, once again, we're supposed to write the answer with rational exponents, so no radical signs. Let's go ahead and use power over root to rewrite everything here. Notice the 200, it would have had a power of 1, so it's going to have a 1/5 when you rewrite it, and then all of the other exponents are in the numerator with a denominator of 5. Just go ahead and simplify those expressions, and the rational exponents, and the only one that you can reduce is 15/5 becoming 3. Now, technically, there are some things you could do to simplify these a bit more, but the main skill that lesson 3 is looking at is the higher level version of applying power over root and reducing these expressions into simplest form. So if everything has made sense so far, then you're right on track. And a lot of what you're about to see is just practicing the skills from the previous lessons at a higher level. Here's one more to try. Go ahead and pause the video, see if you can get this one. And honestly, this is one where if you're able to do a lot of it without me guiding you through it, then you're at a really good spot. So I'll give you a moment to pause and give it a shot. And here we go. So once again, we want to rewrite things using rational exponents. We don't want things in radical form. We need the radicals to go away. So using power over root and remembering that the xy is going to be basically in its own set of parentheses because they are together under the radical sign. They're going to have a power of 1. So we're going to have an xy to the power of 1/2 when we rewrite things. Again, the 2 would be the square root. So that's where that denominator comes from, and then the power of 1 was the numerator. It's just power of a root. The 2 that was in front of the problem gets written right there. If you thought this 2 was referring to the root, sorry, but a tiny small number would be in the root position. This was just a large 2 in front of the entire problem, but it's not going to really change what happens for the rest of it. That's just something to be aware of. In the second part of the problem, we have powers that are already on the x and the y, so those will just become the numerators, and we are going to have a root of 3 going in the denominator, so both of those get rewritten pretty easily. And now notice we can rewrite the first set of parentheses by basically distributing the 1/2 to both the x and the y, so both x and y have the power of 1/2 right now, and 7. Nothing changed from right here with the other x and the y. But now we are at the end of the problem where we will apply the same base multiplying rule. You have to do it twice. There is an x, there's two x's as your bases, so the 1/2 and the 2/3 will have to be added together. You can see we get 7/6 when that is added correctly. And then we will also have to do the same base multiplying rule with the y variables and add 1/2 and 5/3, and that is done up here, and you have 13/6. So that means the x is now going to have the power of 7/6, and the y will have a 13/6. And we have done what the problem asked and written the answer with rational exponents. Here is what the bell work of the next video will be. If you want to see if you are ready and where you need to be, then definitely give these a shot, and these will be explained in the next video. And here are the answers. Hey, good job if you got it. Check them out at the bottom. I'll see you in the next video. Thanks for watching.